Dear students, welcome to another lecture. Today we are going to start a new chapter, Statistical Quality Control. This chapter has a weightage of 12 marks and 8 hours of teaching load. Okay, in this, the syllabus that we are going to cover is basics of statistical concepts. This is more like mathematics, the meaning and meaning and importance of statistical quality control, that also we'll see. Then variable and attribute measurement, control charts, and control charts for variables, X bar, R charts, control charts for attributes, P, NP, and C charts, and then process capability of machine, that is plus or minus 3 sigma or plus or minus 6 sigma, then CP, CPK calculations. All this we are going to see. Okay, now statistical quality control. A quality control system is called statistical quality control when statistical techniques are used or employed to control the quality of a product or to solve the quality problems in an organization. Okay, so when you are employing statistical techniques, that means statistics, what you have learned in lower classes in the subject mathematics, you must have studied statistical techniques. Those techniques we are going to use for quality control. If you are using those quality control those techniques, then our quality control becomes statistical quality control. Okay, so SQC, that is statistical quality control, it consists of 3 general activities. One is systematic collection of the data and recording of the data accurately. This is the first step. Then second step is analyzing the data that is so collected, and the third is practical implementation of the conclusion that we have arrived at after analyzing that data, or the management action. Okay, so these are the 3 steps. First, collect the data, analyze the data, and after analyzing the data, whatever conclusions you have arrived at, those conclusions or those corrections you have to implement. Okay, so these are the 3 activities that are there, okay, in statistical quality control. So statistical quality control is the process of involving collection, analysis, and interpretation of the data to solve a particular problem related to quality. Okay, so statistical quality control is based on law of large numbers and mathematical theory of probabilities. Now this probabilities theory of mathematics we are going to use, and here the numbers that are involved are the numbers are many, like a large number of things. That means we will not be applying statistical data for 5 items, 10 items, 15 items, like that. Large numbers, like big amounts like 50, 100, 200, 1000, 10,000, like that. If they are there, in such a case, we'll be using statistical quality control. Modern techniques of statistical quality control and acceptance sampling have an important role in improvement of quality and enhancement of productivity, creation of consumer confidence, and development of industrial economy of the country. You see, here one is statistical quality control technique, The other is acceptance sampling. Now you may say, what is acceptance sampling? This we are going to study after we finish seeing about statistical quality control. So SQC also we are going to see, and acceptance sampling also we are going to see. So these two things, they play an important role in improving the quality of the products, in enhancing the productivity, and creating of consumer confidence, and on the whole development of the industrial economy of the country. These techniques have been used. Okay, then now what are the benefits of statistical quality control? See, high efficiency, cost reduction, more effective pressure or control on quality efforts, then reduction in scrap, better utilization of raw materials. You see, when you have statistics, no, you will be analyzing each and everything. You see, think of the case where you play cricket, and without any charts, without any statistics, without any numbers, how boring and dull it will be. You will not even know, you see, which bowler to fear and which batsman to fear. If you are a batsman, you have to fear a bowler, because sometimes bowlers will bowl such balls, you will not understand, like, and the other way also. Okay, anyway, you see, think of a game like cricket without the graphs, statistics, and numbers and all those things. It will be boring, and also you will not have better control. You see, now we have the data, maybe for more than 100 years, and we are able to say, oh, India has won last time this place, this person has hit so many centuries, this person scores easily against this bowler, all those things we are able to say. You see, statistics, that's why it's important. Even in our elections, you see when we as government servants, we go and we conduct the elections. I have worked as the presiding officer so many times. You see, every 2 hours we have to give the statistics: how many women, how many men have voted, and what is the number, and whether any literate people, illiterate people, how many literate, how many illiterate people, how many male, how many female. All these statistics we have to give. See, actually, such data gives you power also. That you will understand the things. Similarly, here also, even in case of our products, when we are manufacturing, so much data you can generate. Okay, so with that, statistical quality control, better utilization of raw materials you can do, improvement in inspection standards, you can you'll be able to achieve. Then easy detection of faults. Sometimes if something is erring and going one side, just by looking at the control chart you will know, see, some problem. Even detects in the machines, you can find out because of the pattern in the graphs. Okay, then reduction in consumer complaints and improvement in producer consumer relations, then creating quality awareness amongst the employees and improvement in their morale, and improves improved productivity, reduces wastage of man hours and machine hours, and easy to apply. It may not be so easy to apply, but after a little bit of study, it is easy to apply also, because nowadays so many computer tools have come. The moment you give the data, it will plot the charts. So now that it has become easy also because of the computers. So many benefits are there. It will give you a control. Even now when you are writing exams, the moment you write exams, 10th, the minister says, so many lakhs of people have given our 10th standard exam, so many girls passed, so many boys passed, this percentage of girls passed, this percentage of boys passed, this is the maximum score, this is the minimum score, and all the statistics they give. You see, So statistics, is playing a vital role in keeping in having quality under control. Now, next let us see variable and attribute measurement. Statistical data can be categorized into variable data and attribute data. See, when this data, statistical data, can be grouped under two heads. That is, one is variable data, the other is attribute data. Okay, we will see in detail about what are these two things: variables and attributes. Okay, the statistical methods for analyzing variable data are different, and the methods for analyzing for the attributes is different. You see, for analyzing variables you use some kind of charts. For analyzing attributes you will use some other chart. Okay, like that. So the methods are different. In general, more information can be obtained when data is in variable form. In variable form, you will be able to generate more data. In attribute form, you generate less amount of data. Okay. Now let us see variables. First, variables. Now, what is a variable? You see, suppose we are measuring shaft. Okay, we are measuring the length. Is here example also is given, length of the bar or the shaft in millimeters. This is a variable. Okay, so when measurement is carried out to find out the quality characteristic of the component, the quality is said to be expressed by variables. Now this is a quality characteristic. Length of the bar is a quality characteristic. You see that with the help of some measuring instruments we measure, and what data that is generated here is the variable. Okay. Second, these measurements are carried out with the help of precision measuring instruments, like it can be micrometer, screw gauge, and vernier depth gauge, and wire gauge, and so many gauges are there. You may have studied in metrology and quality control metrology. Okay, now the data obtained is called as continuous data. Such data is called continuous data. The value of data obtained can be in fraction. See, this is where it is deviating from it is we can differentiate between attribute and a variable. You see, variables data can be in fraction. Fraction means it can be 1.5, 1.7, 1.98, such fractions means decimal digits also it takes. What the data of variables, decimal points it can take. Okay, now examples of variables is given here. Dimensions of a part, like length or diameter or thickness or some such things. Okay, hardness in Rockwell units, the hardness numbers is another data. Then temperature in Kelvin, compressive strength in Newton per mm square. These are some of the examples of variables. Okay, now let us see attributes. You see the moment when you say variable, the name itself says it varies. Variables. Okay, the data in in computers, if you say variable, no, some data can be allocated to it, and it can keep on changing, like that it is. Okay, anyway, now let us see here a little bit different sense. Anyway, let us see attributes. See, when a record shows only the numbers of workpieces or items or products confirming or non-conforming to any specified requirements, it is called an attribute. You see here, for suppose in the class teacher comes and asks how many have passed the exam, how many have failed the exam, or how many are present, how many are absent, how many are boys, how many are girls, how many have taken vaccine, how many are not taken vaccine, also such things. The data that gives in numbers. Okay, see, such things are attributes. See, it is recorded with the help of laid down standards such as go, no go gauge. You see, here it is not a measuring precision measuring instruments in which millimeters, centimeters, and fractions of millimeters and such things are there. Here it only has go or no go, like such simple things. You see, with the go gauge, no go gauge, you will be able to say whether an object has passed the test or not. In go it should go, in no go it should not go. Okay, if it is the case, it is accepted, it is passed, quality passed, otherwise it is rejected. Okay, so data obtained is called discrete data. You see, it is discrete data, and this data cannot be in fraction. That means you cannot say, oh, how many have passed, means you cannot say 10.5 students passed. Can you say like that? You cannot say. Here there cannot be fraction. How many pieces are rejected? You cannot say that 50.5 pieces are rejected. You cannot say. Either you have to say 50 pieces are rejected or 51 pieces are rejected. Okay, like that. It cannot be fraction. Whereas variable can be in fraction. Okay. Then value or data obtained after inspection will be an integer number, like 0, 1, 2, and so on. Okay, examples of attributes: number of defectives found in a sample, blow holes in a casting. These are the examples for attributes. Okay, now here we are clearly differentiating between the variable inspection and attribute inspection. Okay. On the left side you have variable inspection, on the right side you have attribute inspection. Now the first point is method of inspection. On the basis of this, let us see how variable inspection or attribute inspection differ. So variable inspection is the method of measuring the quality characteristic to be inspected with the help of precision measuring instruments. So the method of inspection is using the precision measuring instruments. Whereas in the case of attribute inspection, whether they are conforming or not conforming, with the help of some laid down standard like go gauge, no go gauge. This is one of the gauges. This is one of the laid down standard by which the quality characteristic can be can be found out whether it is conforming or not conforming. Okay, so I see, suppose in the class how many passed, how many failed. See, in that case the laid down standard will be some marks. Okay, below this mark, this many marks, one has failed, above these many marks one has passed, like that. Some laid down standard will be there. Okay, then the second thing, the instruments used for inspection. In case of variable inspection, the actual dimensions are measured with the help of precision measuring instruments like micrometer, vernier caliper, etc., and the data is recorded. And the variable here is the length of bar. Okay, whereas in case of attribute inspection, the conformance and non-conformance is usually inspected with the help of go and no go gauges, and parts produced are classified as defective or non-defective. Simple, very simple. They will say whether this has quality checked and found okay or quality failed. Okay, that's all. So there is no way in the middle. See, like that. And exactly so many millimeters, so many fractions of millimeter, even micrometers you will be able to say about the dimension or the quality characteristic of an object. Whereas the information obtained in attribute inspection, it only says whether it is accepted or not. Then about if we talk about time required, you see the variable inspection takes more time, attribute inspection takes less time. Okay, inspection cost, the precision instruments measurement of the variables, no, inspection cost is high, whereas the attribute inspection cost is low. Then how tired the inspectors will become. In variable inspection, sometimes the inspectors may get tired and fatigued, whereas it doesn't cause so much of fatigue in case of the attribute inspection. Then data obtained. This data obtained is called continuous data, and they can have any value, even it can be fractions. Here the data obtained is a discrete data, and it has an integer, and it cannot be fraction. Okay, integer means that is the meaning. Okay, and the examples will be number of defectives cannot be in fraction. Then control charts we're using is X bar chart and R chart. In case of variable inspection, in case of attribute inspection, it is P chart and C chart. Okay, now what are these charts? We are going to study in detail afterwards. So for the time being, just know that X bar R charts are used for variable inspection, P and C such type of charts are used for attribute inspection. Okay, so these are the differences between variable inspection and attribute inspection. Now let us see different statistical quality control tools. Now these tools are histogram, bar chart, frequency polygon, process capability study, various control charts. Okay, these are the different types of tools. Now let us see unit. If you say unit is 1, which consists of number of similar items or objects. Suppose you are producing number of bolts, so if you take any one of those things, it is 1 unit. You see, and like that, there are so many hundreds and thousands in that heap that your company has produced, so each is a unit like that. Okay, then universe or population. Now the universe may be thought of as a common source from which the total collection of unit is obtained. Suppose a big heap of the bolts are there. From that you take a handful of bolts. Now from where did you get this handful of bolts? You got from the universe or the big heap, or it is the source from where you got that. Okay, statistical methods are based on the concept of distribution of exceeding large number of observations, termed as infinite universe or population. You see, here we are statistical quality control we already seen before that it is not used for few number of items, number of items, large population or infinite universe. When large number of observations are there, then only you can apply the statistical quality control. So when you are saying universe or population, means it is that big number from which you are taking your samples. Okay, now cell. If you say cell, what is it? While grouping the data into a frequency distribution, the cell boundaries should be chosen halfway between two possible observations and cell intervals. And the cell intervals should be equal. You see, you remember, I think 1 minute. Let us see whether you see, here there is a frequency histogram. Now see here 0 to 20. Okay, something is missing here. 40 to 60, each one is 10. That means it is starting from 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. See, these are all cells. Okay, and the interval along the scale of measurement of each ordered class is termed as a cell. So these are the cells, this is each cell. Okay, so 10 to 20, 20 to 30, 30 to 40, 40 to 50, these are all I can say cells. Okay, then grouped frequency. When you say grouped frequency, it is an arrangement showing the frequency of occurrence of values in ordered classes. You see, for example, in a class, 60 students are there. We can we can make a chart saying that how many are there between 40 marks to 15 marks, how many are there, 50 to 60 marks, how many are there, 60 to 70, how many are there, 70 to 80, how many are there, you see, 80 to 90, how many are there, 90 to 100, how many are there, like that, you can group them. Okay, so grouped frequency means it is an arrangement showing the frequency of occurrences of values in ordered classes. Say it can be like 40 to 50, some 20 students are there. So that 20 is the frequency or the number, you can say, that is falling in that cell. Okay, the interval along the scale of measurement of each ordered class is termed as a cell. The interval means that 40 to 50, this interval is a cell, and the frequency for any cell is the number of observations in that cell. You see, like 40 to 50 is a cell, and there are 20 students who have scored marks between 40 to 50. That means what? This 20 is the frequency. Okay, are understanding? 40 marks to 50 marks is one cell, and in that, if suppose 20 students have scored in that range, that means either some people may have gone 40, some may have got 50, 42, 45, 47, 49, everything, 50. So between 40 to 50, how many have got? 20 people have got. See, now this 20 becomes the frequency. Okay, that is the grouped frequency. Okay, so that means in the cell how many are falling is the grouped frequency. Okay, then relative frequency. Now relative frequency of any cell is the frequency of that cell divided by the number of observations. How many observations you have taken, and out of that how many are falling in that class. You see, that means this grouped frequency you should divide by number of observations, then you will get relative frequency. Okay, that is the meaning. Then frequency distribution. When the measured sizes of all parts are plotted against the frequency of occurrences of each size in the form of a graph, it is known as frequency distribution. Like you in a cricket match, you plot the overs on the x-axis and the number of runs they scored on the y-axis. You see, now number of runs are the frequency, you can say, and these overs are the cells. Okay, like that. See, the height of the curve at any point is proportional to the frequency occurrence of that particular size. You see, the more number of runs they score, that height will be taller, isn't it? If somebody, suppose in 1 over, in the 5th over they scored 20 marks, that bar will be very high. In the other one, it is only 2 runs they have scored, so it will be a short rectangle, like that. Okay, while grouping the data into frequency distribution, the cell boundaries should be chosen halfway between two possible observations, and cell intervals should be equal. Cell intervals should be equal. In case of cricket, no, cell intervals are equal. It is all, how many? 6 balls, 1 over, 1 over, 1 over, 1 over only we take. Okay, those are the cell intervals. Okay, and Okay, this and the cell boundaries should be chosen halfway between the two possible observations. You see, like when we say for halfway means like see, sometimes when we are saying now the cell is 40 to 50, 40 to 50. Okay, now 40 has come, um, 40. Now which cell you will place, it may be a question like that. So it is chosen halfway between the two possible observations. Okay, you see, these all things because you have already studied this statistics, only that you have to recollect them. Okay, the frequency distribution can be represented graphically by following ways: frequency histogram, frequency polygon, and bar chart. Okay, now let us see frequency histogram. Now frequency histogram is shown in this figure. Okay, in this graph, the sides of the column represent the upper and lower cell boundaries. See here, this is 20 and this is 30. Okay, these sides are showing the cell boundaries, and their heights are proportional to the number frequencies. Now here, you see, this is 5 means this is only 2. This is 1, 2, and this is 6, 2, like that. This is 10. This is around 15. Like that. See, the height is the frequency, and sides of this rectangle are showing the cell boundaries. Okay, in drawing a histogram, it is assumed that the frequency is centered at the mid value of the cell or the class. You see, everything that is falling within this, within this one cell, is everything is in the center. That's what we assume. Okay, that means what, instead of this bar chart, when if you are going to show what see lines we show, we assume that the data is exactly in the middle. That means all the people who got who got between 30 and 40, we assume that everybody is getting 35, like that. The data point will be 35 will be selected, like that. So the mid value of the cell or the class, that is where it is assumed to be. Okay, then simple construction. This is easy. I think you may have drawn so many times such kind of histograms, and the inspection of histogram makes it an effective tool. This becomes an effective tool the moment you see, you will understand. Okay, a random sample is taken from the lot and measurements are performed for the selected quality characteristic. When there is a large variation in the obtained data, then the data may be grouped into cell. Okay, you see, when measurements are taken, we will come to know what will be the x-axis and how the cells should be distributed and all. Okay, then next, frequency polygon. Now this is this also you may have seen. Frequency polygon, it consists of a series of straight lines joining the points which are plotted at cell midpoints with a height proportional to the frequency. It is the same like the histogram, only that it is joined by straight lines instead of the bars. Okay, now frequency polygon has an advantage of plotting several distributions on the same axis. You see here, the disadvantage is only one type of type of data can be plotted in one chart. Okay, whereas here you can plot many number, because the bars are not there, only one line is there. Okay, and these points, these data points, these are assumed to be in the center of the classes. Okay, like that. Okay, see, when we are plotting several distributions on the same axis, what is happening, you'll be able to make comparisons easily. Comparisons are possible. Now, which is the comparison is not possible in the case of histogram. You see, even in cricket, when you want to compare how the two teams are scoring, they use line, not the uh, the runs that they, or the what is that, the histogram they won't use, they use frequency polygon. Okay, now next is bar chart. Bar chart is a graphical representation of the frequency distribution in which the bars are centered at the midpoint of the cells and the heights of the bars are proportional to the frequencies in the respective cells. You see, this is like that. See, suppose in January you have suppose this is sales and these are the months on the x-axis, in the y-axis there are sale of items or something like that. So in January how many this here, and February how many this, these need not be some kind of cell boundaries and other things. You see, whereas histogram, these classes, these cell boundaries, they are uniformly placed, whereas here it may not be like that in case of bar chart. And there can be gaps also existing like this. So that is the difference between the histogram and bar chart. Now, central tendency. When you say central tendency, what do you mean? You see, this it can be defined like this: when accurately measured, the dimensions of most of the components tend to concentrate close to the middle of the two extremes. Whatever two extremes are there, normally we turn to we see that towards one particular thing, one central point, all the measurements are concentrating. You see, that's why this normal distribution curve and other things also come into picture. Okay, there also we see towards the ends it goes down, but in where the mean is there it is like a bell shaped, it is tall bell in the middle. Okay, like that. See, that is the central tendency. Two extremes mean the highest and lowest measured values, and it is seen that it is concentrated towards the middle of the two extremes. So such thing is called as central tendency. So alternately, the maximum number of components will have the size equal to approximately close to the middle size, and the sizes bigger or smaller than the middle size will be less frequent and lies near the two extremes. Okay, see, in either way you can explain central tendency. Now, central tendency is usually expressed in three ways. It is expressed as a average value, this is arithmetic mean. Then middle value, that means it is median or the most frequently occurring value, that is mode. Say mean, median, mode, this you may have studied in statistics. The same thing we are studying here. Okay, now a little bit explanation about arithmetic mean. Arithmetic mean is x bar. Now, arithmetic mean is the average of all the values of variables in the sample. Suppose x1, x2, x3, x4, x5, x6, like that, so on to xn. So suppose n number of values are taken. Okay, their arithmetic mean x bar can be given as the summation of all these things, that is x1 plus x2 plus x3 plus so on plus xn, divided by the total number of total number of values n. So otherwise it can be shown as sigma x upon n. Okay, this is capital sigma, that is summation, okay, sigma x upon n. This is the formula for finding out the arithmetic mean. Okay, and it can so happen that x1 occurs f1 times, x2 occurs f2 times, like that, and xn occurs fn times. Then what will be the arithmetic mean? Then you have to see how many times this frequencies, this see this number n can be found out by adding all this, by adding all these frequencies, f1 plus f2 plus f3 plus f4 plus so on to fn. This is sigma f. So in that case, the arithmetic mean x bar can be given as f1 x1 plus f2 x2 plus f3 x3 so on fn xn divided by f1 plus f2 plus f3 so on to fn. So otherwise it can be mathematically shown as sigma x upon n, or sigma fx upon sigma f, okay, or sigma fx upon n. Okay, like this you can give the mean mathematically. Okay, now let us see about the median. Now when we say median, when all observations are arranged in ascending or descending order, then the median is the magnitude of the middle class. Everything is arranged in the in the ascending or descending order, and whatever falls in the middle, that is the median. You see, case 1, if number of observations n is odd. See, suppose if 3 people are there, the middle fellow 2. Okay, 3 is odd, no? So if 3 are there, the middle fellows, whatever his value is, that is the median, like that it is. If number of observations n is odd, their values are arranged in ascending order, then median is n plus 1 by 2th value. That suppose this is 3. 3 plus 1 is 4. 4 by 2 is 2. So that is central thing. You can find out like that. Then otherwise, case 2, if the number of observations is even, then the values are arranged in ascending order, then the median is taken, the average of n by 2th value and n by 2 plus 1th value. Okay, the average of these two. Suppose 4 people are there. Okay, then if 4 people are there, 4 by 2 is 2 and 4 by 2 plus 1 is 3. So second and third, that average if you take, you will get the median. Okay, that way when odd numbers are there, even numbers are there, both cases we have seen. Now next is mode. Mode, if we say what it is, see, it is that value which occurs more frequently in a frequency histogram or a frequency polygon. See, it is the observed value corresponding to the high point of the graph. For example, if the recorded observations are, see, this is the data, suppose 4 5 4 2 3 4 6 4 9 6 9 7 4. From these observations recorded, we find that the value 4 occurred the maximum number of times, most frequently, that is 5 times it occurred. So whichever is coming the maximum number of times is the mode. That means mode is 4 in this case. Okay, so this way arithmetic mean, that is mean, then median and mode, these are found out. Okay, now next let us see about the dispersion. Now dispersion means, disperse means what? Disperse means things going helter skelter, like, or everybody, suppose you are in the line, you are in the assembly and you said you are dispersed, you can go. That means everybody will go. Somebody will go to drinking water, somebody will go to their school bag, college bag or something, somebody will go into the classroom, they will go here and there. Like that, that is the dispersing. Okay, dispersion is defined as the extent to which data is scattered about the zone of central tendency. You see, whichever is the center, from that, how much this side and how much that side it is falling. So that is the dispersion. See, concepts of dispersion and central tendency are opposite to each other. See, central tendency means everything is in the center. Dispersion means everything is scattered. See, these two are contrary to each other. Okay, these are opposite to each other. Then dispersion usually is measured and expressed in three ways. Dispersion for when we are talking about dispersion, now these three things come. One is the range, that means from where to where it is falling. Okay, that is the range. Then second is standard deviation. Then third is variance. Okay, now range. What is the range now? These three, let us see. Range is defined as the difference between the largest observed value and the smallest observed value. Now suppose in a class of 60, the minimum marks scored are 40, maximum scored are 90. So what is the range? 40 to 90 is the range. Okay, minimum value and maximum value. Okay, like that. See that the largest observed value minus the smallest observed value, that is the range mathematically. See, it is the simplest measure of dispersion in a sample. It is particularly used in plotting control charts. Actually, we are going to see many control charts, so they are known. This is used. Okay, this is the first one. This is the first way of expressing the dispersion. Second way of expressing dispersion is standard deviation, sigma. This is small sigma. Okay, standard deviation is defined as the root mean square of the deviations from the arithmetic mean. You see, root means square root. This is the square root. Okay, mean square. Square is this here. You know this. You see, now x bar. This is the mean. X1 is the value, observed value. X2 is the observed value. Like that, all these are observed values. But x bars are same. Okay. So how much from the mean this variation is? What is the difference here? Not only the difference square it is. You see, the root mean square of the deviation. This is the deviation. This is the deviations square, and this is the root. See, the root mean square of deviations from the arithmetic mean. Okay, that is the standard deviation. That is sigma is equal to square root of x1 minus x bar whole square plus x2 minus x bar whole square plus so on xn minus x bar whole square divided by n. That is the number of observations. If so, it is also called as RMS value. Root mean square value is RMS value. It is denoted by small letter sigma, Greek letter. Then x1, x2, x3, xn are the number of observations. Then x bar is the arithmetic mean. Mathematically, this can be the standard deviation can be shown like this. Yeah, standard deviation. Yeah, it's the same thing. Now variance. Now variance means what? Variance is the sum of the squares of deviations from the arithmetic mean divided by the number of observations. You see here, no, variance is nothing but the standard deviations square. That is sigma square is variance. That means what? In this formula that we have got now, only the square root if you remove, you will get variance. Okay, so variance is equal to sigma square is equal to x1 minus x bar square plus x2 minus x bar square plus so on xn minus x bar square divided by n. So this is the variance. So these are the three things that we have seen for dispersion, range, standard deviation and variation. Okay, so today we will stop here and we will continue in the next lecture. Thank you.